Hey y'all, welcome back to the HackShack. Today we've got another box from the folks at Hackerboxes. This is Hackerbox 113, and the name is Hardcore.
Hardcore parkour!
Let's get this on the bench and see what we have inside here. This looks like the USB STC auto programmer. This looks like the STC 5.1 programming target kit. Looks like a zip socket here, some resistors, a blank STC 15W408AS MCU, and this is a blank STC 8G1K08A MCU. This looks like the STC 8G1K08A based spiral LED kit. See, here's the PCB, and we've also got this 3x AA battery holder. This is a dip chip extraction tool, or sometimes you might hear people call it a chip puller. This looks like the STC 15W408AS based embedded calculator kit. Got a PCB in here, a bunch of buttons, another MCU, some displays, speaker, battery holder, some labels there for some keys, all kind of stuff in there. This looks like the acrylic enclosure kit that goes with the calculator. This is the exclusive reverse engineer iron-on patch. Looks pretty cool. And this is the PCB for the STC 51 programming target kit. Here we've got our Hackerbox 113 collectible reference card. It's got a cool picture of the calculator there on the front. And on the back, we've got our two MCU chips there and their pinouts. Pretty cool. And last but not least, we've got our exclusive metallic hacker sticker sheet. That's pretty fun. Before we move on, I'd like to take a moment to thank today's sponsor, PCB-Way.
Got a design ready? PCB-Way makes it easy to bring it to life. Upload your files, pick your options, place your order. Whether you're a seasoned pro or just tinkering for fun, PCB-Way delivers quality boards fast.
Just like they always do, the folks from Hackerboxes have included a great set of instructions here available on Instructables. I have a link to that in the description. Even if you don't have the Hackerbox, you might find it pretty handy. Now, the first thing our Instructable recommends we do is use something to mark our pre-programmed kit MCUs so we don't get those mixed up with our blank ones. We don't want to accidentally overwrite those. And like it suggested here, it said you can even use some of the shiny metallic border from your sticker sheet. And that's exactly what I did here. I cut off a little piece, then I stuck some to each one, as you'll see here. Alright, the next thing the Instructable has us do is complete this STC 51 target kit. Now that socket only goes in there one way, and you want the little flip arm, when it's like that, to be up towards the little 4 horizontal holes you see there. And that's the correct orientation. And then you just solder all these pins in. Then I put both of my resistors in. You can kind of form them a little bit to make them line up. They don't have an orientation. I usually stick them in, bend the legs back, solder them in place, and clip the excess off. So next with your LEDs, you want to pay attention. One leg is shorter than the other on your LED. That is the cathode, and that's going to line up with the marking on the PCB that has that flat edge. As you can see here again when I'm showing you the second one, short leg goes in there with the flat edge, and there's actually a little flattened edge on the body of the LED too. And then I just bend those legs back and solder those in place. This 4-pin male programming header kind of goes in like this. I used a little bit of blue tack to hold that in place and then soldered those 4 pins. And then I took the blue tack back off. Next, I cleaned things up a little bit with some alcohol and a swab. Next, I connected those headers we just soldered to the STC programmer using the diagram in the Instructable. But if you notice, I don't know why I didn't catch it at first. I wasn't thinking about it. I was matching them up. But since we're talking back and forth to something, we need to flip our transmit and receive. You know, transmit can't hook to transmit and receive can't hook to receive, or no communication will take place. So you'll see me totally miss it right here, and then I realized my mistake, and then this next shot you'll see that I flipped those two around and it matches the Instructable. Next, the Instructable advises us to get our tool chain for programming our chips. And the first thing it tells us to get is this SDCC, and that goes over to SourceForge, and follow that link. Just watch out for miscellaneous crap that seems to have littered SourceForge since the good old days. So grab that. And it's just like your typical Windows program, next, install. I think on my PC it may have given me a little warning about it, but I just said okay, go ahead and go, and then that'll install. And this part right here next, make sure you do have this checked to add that to the path. Next, the Instructable tells us to download the STC ISP programming tool, and we'll go over to that page and get the one that we need. And it's just a single exe. Like it says here, it doesn't need to really be installed. You just execute it as it is. And oddly enough, this was a RAR archive, but luckily I had 7 installed. I was able to open that up and look inside. Next, the Instructable advises us to grab this hello.c and this mystc.h header file. So we'll grab both of those. I just made a little folder to place them in together. And when we look inside that C source code, you'll see a little section that says to grab out, and that lets us make a batch file that we're going to use to compile this. And when that finishes compiling, it's going to produce a .hex file. And that will be the file that we reference when we push this code to the chip. After I had that compiled, I stuck the blank 28-pin chip with the notch toward the lever, and then I hooked the programmer up to the USB on my bench PC here. And then we got back into the STC ISP programming tool. Right, the first thing you do is make sure you've got the right STC 15W408AS chip selected. Then you want to make sure your port that you've selected is what shows up as CH340 for your programmer. And then you want to change this frequency right here to 12 megahertz. And then you want to go to Open Code File and navigate to your hello.hex file. And then hit the download program. That should push it to the chip. And now when we look at it, it should be blinking the P3.2 LED at 1 Hertz, or about 1 time a second. And as you can see here, it looks like it's doing that. Next, the Instructable tells us to listen for serial output. Back in the program, we're going to go to the USB CDC UART helper tab. We're going to make sure our correct COM port selected. We're going to set the baud rate to 2400 and then hit Open COM. And we should see repeated messages here. Yep, looks like that's working. Hack the planet. Next, the Instructable says to put our spiral LED kit here together. And it's pretty straightforward. You've got some resistors and their orientation doesn't matter. You've got some push button switches to put in, and they can only fit one way, so they're not too bad. And then you've got 19 red LEDs. And the main key there is to look at the markings on the PCB, make sure the flat side on the silk screen matches up with the flat side of your LEDs. Next, our dip socket's going to go in, and we want to match the notch on the socket to the notch on the silk screen on the PCB. Next, our IC is going to go in, but you want to make sure that the legs are good and straight, and you may have to use the edge of your table to kind of bend the row together to make them fit. You don't want to force it, and it should seat in there properly. At the end here, we're going to connect our battery pack leads, and red goes to positive and black goes to negative, and that's it. So I hooked things up to give it a quick test, and you can notice this diode D6, that LED, was not lighting up. So that got me wondering, and I even went back and looked. If you see here, it looks like I'm about to put it in backwards, but at the last second before I put that in, you see I flip it around, and even when it's sticking through the back of the board, you can see how it's the shorter leg that's facing the correct direction there. So I got out the solder sucker and applied a little heat while pulling and managed to get that out. And then I kind of got it back running again and flipped it around because I didn't look at the replay at this point, and I thought I surely had it backwards. But I tried it in both directions and it did not light up. Even though it's not soldered, it should have kind of shown a little bit of light there. So then what I did was I grabbed one of the spare LEDs that was in the kit, and you'll see when I kind of place it in there temporarily without soldering it, it lights up right away. So I think I just had a bad LED there because, you know, on the replay, I do have it in the right orientation. So I seated that in all the way and soldered it in place, cut the leads off, and gave it one final test, and everything looked okay. So the next thing the Instructable has us work on is our calculator kit. And I just want to highlight a big note here from the Instructable. It's basically saying, you know, do not have the battery in there when you have it on USB power. So take heed for that warning. It also says don't populate that programming header if you're going to put it in the acrylic case. And next, basically just got all the parts laid out and ready to go here. I'm not going to talk a bunch over this one. We've got a bunch of switches, some labels, some displays. You see the battery like I already mentioned there, a battery holder, got a capacitor, and a little sound speaker piezo there. And I'm just going to run through and pop this thing together. And you'll see here, I populated all these switches in place. I don't know why I did that, because clearly there wasn't a good way to hold them real tight. And you'll see when I flip them over here in a minute that they basically, most of them fall out. And you'll see a few different things I end up doing here. And one of the things mainly I do later is kind of put a little solder on one corner and get that flat, and then come back and do the rest. You might see some other variants of what I do here, but if you got the kit, just, you know, use your best judgment and use what works for you to make sure you get these switches flush to the PCB. So for the labels, I took the decals off and stuck them inside the little clear pieces first and kind of pressed them down with my little helper there, and then snapped those onto all the tops. Now it's time to put the MCU in. I just want to make sure to put the notch there to the notch on the socket. With these big dip chips like this, or even small ones, you may need to press it against the side of the table to make them all kind of evenly bend in at the same rate. And sometimes you have to kind of flip that over and do a little bit of a back and forth, but eventually you'll get them where they'll go in there. You just don't want to force it, and you don't want to do something weird where you've got one leg going out in a crazy direction that gets almost bent so hard that it'll fall off, because then you're going to be in bad shape. I almost forgot to put this capacitor in, so I made sure to pop that in there real quick. So now it's time to give it a first test. I popped the coin cell battery in there, and I know initially I didn't see any response out of the displays there. I don't show every single thing I tried, and I basically manipulated this, tried to make sure it was real nice and tight and pressing against there. But initially nothing I did would show any activity. So I hooked up the USB cable just as a check to make sure it'll power on. And as you can see here, it worked okay when I did that. I eventually goofed around that connector enough and applying pressure that I got it to work pretty consistently on just the battery. Next thing I'm going to show you here is how I put together the clear acrylic case. There's not a lot to say here. You can kind of see what I'm doing. If you want to see the detailed instructions, just check out the text in the Instructable. I popped the battery out for one last test here and popped it onto USB power. And you can see there's another feature here in this calculator. When you hold down this button for a second, it puts it into this mode where you see that E up there. And there's some examples from the Instructable, and you'll see I'll type those in. And it's like you're typing in the color bands of a resistor. And then it'll tell you the value of the resistor. And it looks like it works okay. As we get near the end of the hands-on portion of the Instructable, it has this section about exercises and gives a couple of ideas of some things you can try to kind of modify the code that would run on the little LED spiral kit or on the calculator kit itself. And if you notice what box number this is and what month I'm releasing this, you can see I'm way behind. And so I didn't have a lot of time to mess with this. I did goof around and try to modify some code for the LED spiral. I loaded up the blank 8-pin MCU into the STC51 thing, and initially I did it wrong. It needs to be like this in the picture, and later on I fixed that. Then I used the same program from earlier to push the code that I compiled. It doesn't work as I wanted it to yet, but you can see that it behaves differently from default. So that does prove that we can, modify and change code on our own to get a little more hardcore with these microcontrollers. I'm looking forward to hearing about anything you all may have done. I know this one's a little bit old, but if you're seeing this for the first time, throw something in the comments and maybe tell me where to find what you may have done if you did any mods to code or did anything neat with your devices from this kit. There's a ton of other cool stuff to check out in the Instructable. Again, that's free. Just follow the link in the description. Lots of other neat topics that you may not be familiar with that are very cool to dive into. I've really enjoyed messing with this Hackerbox. I'd never played with those particular microcontrollers before, and it was neat to get some experience with how that all worked with that particular tool chain and so forth. It looks like we're going to have ourselves another giveaway. The nice folks at HackerBoxes have graciously offered to send a HackerBox 113 to a randomly picked commenter. We'll be picking the comment on July 26, 2025. And remember, HackerBoxes only ships to US addresses for this giveaway. So if your comment's picked, but you don't have a US shipping address that we can use, we'll need to pick someone else. Good luck. At the time of this recording, there are still HackerBox 113s in stock. If you don't win the giveaway, you want to get one, check them out, or go ahead and subscribe. Hey, if you made it this far, thanks for watching. Hope to see you again next time. Take care. Bye-bye.